So anyway, 0.4 pints in 3,500 gallons. Obviously, we cannot use this the way it is because they're different units. We need to do some converting. Now, I can convert the 0.4 pints into gallons. Kind of going to suck. So let's do the 3,500 gallons into pints. We'll put that over 1. Gallons on bottom. Now I'm going to go to quarts first. 1 gallon is 4 quarts. Gallons cross cancel out. Now I'm going to get rid of the quarts. Quarts to pints. 1 quart is 2 pints. So that's going to put us in pints. So on top, it's still 0.4 pints. We didn't change that at all. On bottom, 3,500 gallons ends up being, is it 28,000 pints. And now then we have to turn that into parts per million. So how much would that be out of a million? $14.28571428.571 approximately. We're going to call it 14.29. I didn't tell you where to round that. If you round it to 14.3 or even just 14, I'd have to accept it. Did anybody have it right? Yeah? Sensing some sarcasm there. Okay, so convert 280 parts per million to a percent. That's 280 out of a million. A percent would be out of 100. Pen's getting a little touchy. Cross multiply and divide there. That is 0.028 out of 100 or 0.028%. What you think? Good stuff? Do you guys have any questions off the homework from yesterday out of the packet? Any of those that you want me to go over? Jordan, I notice you're not looking at your homework, which I'm assuming means either you just aced it all or you didn't even look at it, one of the two. Put his name on it. That's a start, I guess. Note I did leave the recording on, so that will be in the YouTube recording for future generations to. Okay, so yeah. Did you have any that you wanted to go over? No? Okay. So now let's take a peek at our new topic. We're still dealing with these percents and allowances and tolerances and stuff and errors. And we've talked a lot about resistors having a raw tolerance and a relative tolerance. Remember, a relative error or tolerance we're going to be actually looking at tolerance for this example. Might look like this, 1.2 kilo ohms plus or minus 10%. That's a relative tolerance or allowance because it's a percent. An absolute tolerance or error, once again, I'm going to be using this as a tolerance or allowance. Might look like 1.2 kilo ohms plus or minus 120 ohms, where it's an absolute amount here, not a percent. I'm going to assume that after last semester, you guys know how to switch between the two of them. To confirm that, let's just give you a couple. Convert 3.5 kilo ohms plus or minus 20% to an absolute. And convert 2.8 kilo ohms plus or minus 140 ohms to a relative. I'll give you a couple of minutes to do those. So up top here, 20%, 20 over 100 equals, now we're gonna put the 3.5 kilo ohms as 3,500 ohms. Cross multiply and divide, that ends up being 700 ohms. So that is 3.5 kilo ohms plus or minus 700 ohms. Look right? Second one, going the other way, we have to find the percent. For 140 ohms out of 2.8 is going to be 2,800. Cross multiply and divide, we get 5 there. So that is 2.8 kilo ohms plus or minus 5%. Why do we need to be able to switch back and forth between them? Well, because when we go to do operations with them, certain operations involve the relative allowance or relative error, and other operations involve the absolute error. Now, first of all, are you guys pretty comfortable with the color code? Do I need to go over that at all? Is this your color code? If I give you red, green, red, silver, are you guys capable of reading it? Chart? You don't have the colors memorized? Okay. The mnemonic I was taught when I was in college for remembering this, I can't use anymore. So I'll use a slightly inappropriate one. Bad beer rots our young guts, but vodka goes well. Get some now. So with the letters black, brown, red, orange, yellow, green, blue, violet, gray, white, and then gold, silver, and none. Black, of course, is a 0. Brown, 1, 2, 3, 4, 5, 6, 7, 8, 9. Gold, silver, and none. Gold actually can be used as a multiplier. Gold is I'm trying to remember, is it -1? -2? For tolerances, of course, gold is plus or minus 5%, silver is plus or minus 10%, and none. Sometimes they use black instead of no tolerance band, plus or minus 20%. So if there's black in that tolerance band, it is plus or minus 20%. Brown is actually plus or minus 1%, and red is plus or minus 2%. A lot of people don't realize that there are, brown and red tolerance bands. Those are pretty much military grade. You don't see those in many electronic applications. just because they're very expensive to make. So anyway, what we have up top here, red, green, red. Red, of course, is the number 2. Green is the number 5. The third band is a power of 10. That's 10 to the power of 2. Scientific notation. So that is 25 times 10 to the power of 2 is 2,500. And of course, silver is plus or minus 10%. Most places don't talk about the gold and silver being -1 and -2. Those would only be used as powers of 10. For example, if we had a yellow, orange, silver, and then red. Yellow is 4, orange is 3. Silver being a -2 would be times 10 to the -2. So that is saying is 0.43 ohms, plus or minus the red is 2%. We're probably not going to run into too many examples like that, just so you know. So anyway, dealing with these absolute and relative errors. Let's say I have 2 resistors. Oops, I need to go back for that for you. Okay. Up here? Okay. Okay. So if we want to look at a little bit more realistic view of combining resistances, if we're looking at a circuit like this that has these 2 resistors in it, to find RT, the total resistance, we're going to be adding those 2 resistances. When we add or subtract, allowances, tolerances, even errors, we use absolute errors or allowances or whatever we're using. So for each of these, we have to find the absolute allowance. So 2.4 kiloohms is 2,400 ohms. 10% is what? 240 ohms. 3.5 kiloohms is 3,500 ohms. 20% of that is 700. So as we are adding those resistances, 2,400 plus 3,500 is 5,900. When we're adding or subtracting, doesn't matter whether we're adding or subtracting, we add the absolute errors. Even if we're subtracting the whole numbers, we still add the absolute errors. So 240 plus 700 is 940 ohms. So that total resistance is 5.9 kiloohms plus or minus 940. Now, this was given as a relative tolerance here, or allowance, so we should convert it back to a relative allowance. So we have to find what percent that 940 is out of 5,900. And we get that it is 15.93. So that's 5,900 ohms. Actually, I'm going to change it to be 5.9 kilo ohms plus or minus. We're just going to go 15.9% is the total resistance. Most likely, you'd probably even just go to 16%. Does that make sense the way we did that? I'm going to have you guys try one. I'm going to have you subtract. Where we have 240 volts plus or minus 20%, and we're going to subtract from that a 160 volt plus or minus 10%. So I'll give you guys a couple minutes to do that, and we'll talk about it in a couple minutes. Okay, so we've got the 240 volts and the 160 volts. We have to find 20% of the 240, which of course is 48 volts, and 10% of the 160, which is 16 volts. And we are subtracting. 240 minus 160 is 80 volts. Does this become plus or minus 32? Say no. Why not? You always add the errors. Whether you're adding or subtracting, you always add the errors. So 48 plus 16 is 64 volts. So that's actually 80 volts plus or minus 64 volts. Now we do want to convert that back into a percent. So blank over 100 equals 64 over 80. Cross multiply and divide, you're going to get 80% there. So that's 80 volts plus or minus 80%. Well, you might be wondering, is that really accurate? Well, this gives a range here. Minus 64 volts would be 16 volts. Plus 64 volts would be 144 volts. Is that really the range given here? Well, let's take a look. Up here, we've got 240 minus 48 would be 192. 240 plus 48 would be 288. Down here, the largest value would be if we subtracted the smaller value of this from the bigger one. 160 minus 16 is 144. We're going to subtract that from the larger one. Oh, just a second here. Got to be careful. 160 to 144 and 176. That's not the direction I was expecting that to go. Oh, my 1 disappeared. That's why. Okay, so now when I go to subtract, 192 minus 176 is 16 volts difference. That's if I take the smallest value of this one minus the largest value of that one. That's the smallest possible difference. The largest possible difference is if I took the largest value of this one minus the smallest value of this one. 288 minus 144 is 144. So that does give us the same range as just combining the absolute errors. As you can see here, when you're working with these, the errors do build up rather quickly. Any questions on those? when you multiply or divide, you add the relative errors. For example, let's say that we are going to have, oh, let's see here, 2.5 kilo ohms plus or minus 10%, and 4 amps plus or minus 20%. If we go to multiply these, since they're already in relative errors, I don't have to convert anything. I am going to convert the 2.5 kilo ohms to 2,500 ohms times 4 amps is going to give us what? 10,000 volts. 2,500 times 4. Ohm times amp is a volt. Plus or minus 30. You got it. 10 plus 20 is 30%. So if we have a current that is 250 milliamps plus or minus 50 milliamps, and a voltage source that is 400 volts plus or minus 20 volts. Find the power. First, each of these has to be changed into a percent. So I'm going to move this. This is going to be 200, actually 0.250 amps. I'm going to change that to 50 is what percent of 250? 20%. Any questions on where I came up with that 20%? It's blank over 100 equals 50 milliamps over 250 milliamps. Cross multiply and divide. That'll be 20%. Down here, 400 volts. 20 is what percent of 400? 5%. Good. Same setup. It would be blank over 100 equals 20 volts over 400 volts. And cross multiply and divide. So anyway, now we've got the 0.25 times 400 is 10 watts. Plus or minus 20 plus 5 is 25%. If I wanted to convert that back into an absolute, since these are absolute, that would be 10 watts plus or minus 2.5 watts. Again, how did I get there? 25% is 25 out of 100. How much is that out of 10 watts? Cross multiply and divide is 2.5 watts. What do you think? Okay, so we've got about 14 minutes left. I want to give you guys some time to start on these. There's going to be two things if you want. It is in your little book or in that packet I gave you last week. Unit 34. Then in the other packet, page 264 through 265. Let's try to write the right number down here. Problems 1 through 20. So unit 34 out of your little book or out of the packet, that is your color code. Stuff is in there. And then some tolerance, absolute and stuff, relative tolerances. The other packet then is the adding and subtracting with the errors. Any questions? Okay, I'll let you guys have the last 12 minutes to get started on those.